All right, so in this video, we'll go ahead, we'll do some indifference using radians. We just did degrees, so now we'll do radians. So if I give you cosine of 11 pi over 12. Sure, you can sit here and you can translate that over into degrees and do that if you want to. You don't have to though, and I think it makes it a little bit easier with how our formula sheet is, because our formula sheet doesn't give you the degrees. So to keep it in radians, it kind of helps out a little bit. So before I said just subtract 45, right? Because you're always going to have a 45 involved. Same idea, except I'm going to subtract pi over 4. So if I have 11 pi over 12 minus pi over 4, well, I'm going to go ahead and have to figure that one out. So I have to multiply by 3, because if I'm adding and subtracting fractions, I have to have a common denominator. So that's going to get me 11 pi minus 3 pi, which is going to get me 8 pi over 12. And then that reduces. You can divide both of them by 4, so that gets me 2 pi over 3. So if I take 2 pi over 3 and I add pi over 4 to it, I get 11 pi over 12. Okay? Same idea as if you did 7 minus 2 equals 5. You do 2 plus 5 and you get 7. Same idea. I'm just working backwards. So we have cosine of 2 pi over 3 plus pi over 4. Remember, again, you could do pi over 4 plus 2 pi over 3. It does not matter, just as long as you're consistent. Okay? All right. All right, so I'm going to put this into the equation. So I've got cosine 2 pi over 3 times cosine pi over 4 minus sine 2 pi over 3 times cosine, not cosine, okay, times sine pi over 4. Okay, so you've got all of that. Now you just need to go ahead and look at the unit circle and plug it all in. So what I'm going to do is I'm going to look at the unit circle here. 2 pi over 3 is over here in my second quadrant. I've got cosine there is negative 1/2. So I've got negative 1/2 times square root 2 over 2 minus sine of 2 pi over 3 is going to be square root 3 over 2. So that's square root 3 over 2 times sine pi over 4 square root 2 over 2. So when I combine those together, I get negative square root 2 over 4 minus square root 6 over 4. So over the same denominator, negative square root 2 minus square root 6 over 4. If you wrote it as negative square root 6 minus square root 2 over 4, it doesn't matter. It's the same exact thing. It just matters that your subtraction sign goes with the correct thing. All right. Then we've got sine of 7 pi over 12. So same exact idea as the last one, is I take 7 pi over 12 and I subtract pi over 4. So times 3 times 3. So that's going to get me 4 pi over 12, which that's going to reduce to pi over 3. Okay? So what I really have is the sine of pi over 3 plus pi over 4. Okay? So if I was to take that and consider pi over 3 is 60 and pi over 4 is 45, I'm really doing the sine of 105 is what I'm doing. All right. So putting this into the equation, I've got sine pi over 3 times cosine pi over 4 plus cosine pi over 3 sine pi over 4. All right. So now I look at the unit circle. At pi over 3, my sine is square root 3 over 2. So that's square root 3 over 2. Cosine at pi over 4 is square root 2 over 2. Cosine at pi over 3 is going to be 1/2. And sine at pi over 4 is square root 2 over 2. So when I combine these together, I get square root 6 over 2 plus square root 2 over, oops, just kidding. This is what happens when you rush. Square root 6 over 4 plus square root 2 over 4. See, would have been on the wall of fail there, saying 2 times 2 is 2. Square root 6 plus square root 2 over 4. And there's your answer. Okay? So it's really, really, really not too bad. It's should be a nice change of pace from what we've been doing. The next couple questions that we've got are, they look ugly, but they actually tend to be the easiest ones. So I've got cosine 218 times the cosine of 97 minus the sine of 218 times the sine of 97. So this is when I have to look at those initial equations that I had. So I have cosine, cosine, sine, sine. So if I'm looking back at these equations all the way back here at the beginning, the one that goes cosine, cosine, sine, sine is cosine. So that's going to be what I'm going to be doing. I'm either going to be doing cosine alpha plus beta or cosine alpha minus beta. So if I go back and look, I've got a subtraction sign here in the middle. So the cosine one that has a subtraction sign means that initially I'm adding. So I actually have cosine, here's alpha, here's beta, of 218 plus 97, because I've added them together. So 218 plus 97 ends up getting me 315. So really, ultimately, what I'm doing is I'm doing the exact value of cosine of 315. Well, shoot, that's on my unit circle. It's right over here in the fourth quadrant, 315. I'm cosine, so it's the x value there, so it's square root 2 over 2. So my answer is square root 2 over 2. Done. It's that easy. So same idea as well on the next one. If I have sine 5 pi over 9 times cosine pi over 9 plus cosine pi over, 5 pi over 9 sine pi over 9. When I have all of that together, I've got to look. So if I look at my original equations, sine times cosine plus cosine times sine, that's going to be sine. So I'm taking sine. This is alpha, this is beta. When I'm adding for sine, I'm also adding my alpha and beta together. So I've got sine 5 pi over 9 plus pi over 9. So when I add those together, I get 6 pi over 9. 6 pi over 9, which reduces, because I can divide both of those by 3, to 2 pi over 3. So ultimately what I'm looking for here is the sine of 2 pi over 3. So if I go here on my unit circle, 2 pi over 3 right here, sine is square root 3 over 2. Square root 3 over 2. Done. So those look hard, but they're really not. Those are the ones that you're going to be like, can we have a whole test on that, please? But no, you can't. So ultimately, I think this is going to be a really, really nice change of pace for everybody, and we should be okay. So let me know if you have any questions.